In this video, we're looking at a spring gun that's launching a ball bearing, and we're told the spring is compressed from its equilibrium length to a compression distance of 45 centimeters. The ball bearing is 75 grams, and it comes out of the gun at 12.5 meters per second, and we're also told the time for the launch process. And there's three parts to the question. We want to find the initial energy stored in the spring. We want to use that to compute the spring constant. And then finally, we want the average power output of the spring during the launch. So the basic concept behind part A, where we're looking for the energy stored in the spring, is that we can quickly get the kinetic energy in this ball when it leaves the gun. That's just 1/2 mv squared. We plug in the mass in kilograms, that's 0.075, and we have that launch velocity of 12.5. Make sure you square that. Into three significant digits, we get 5.86 joules of energy. And of course, that energy came from the spring decompressing. So the initial energy stored in the spring is the exact same 5.86 joules. And there's the answer to part A. Now in part B, now that we know how much energy was stored in the spring and we know how far it was compressed, we can use the formula for spring potential energy. That's 1/2 kx squared. We plug in how much energy was initially in that spring. That's 5.86 joules. K is the unknown here, and our compression distance was 45 centimeters, so that's 0.45 meters squared. And we solve for K. Into three significant digits, this comes out to 57.9, and the units of spring constant are newtons per meter. Finally, we want the average power output for this spring, and that's simply how much energy was transferred divided by how long it took. We were told in the problem the launch process takes about 0.226 seconds. And again, our formula for average power is just how much energy was transferred divided by how long it took. It's a rate of energy transfer, and that's 5.86 joules of energy transferred out of the spring in 0.226 seconds. And when we run the numbers on this, we get 25.9 joules per second. But remember, joules per second have a special name. Those are watts. So we've got 25.9 watts of power being delivered by this spring on average during the launch, and we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.